Okay, so there are some rules that from time to time I share with the student in the class. So the first one is basically is draw the Lewis structure. So that's really the first thing we need to do. Now we also have to remember the Lewis structure does not or do not show geometry. Just how many bonds we have and electrons on shared pair of electrons. We need to pay attention to the central atoms. Then we go count the number of domains attached to the central atom. That means bonds and lone pairs of electrons. Then we count the number of lone pair, and then we check the table. So let's check the table. If I bring this up a little bit, see if it works. So using the document camera as looking at the monitor or this screen. So if you have let me make it a little bit bigger, see if it works. Yeah, a little bit better. So if you have 2, 3, 4, 5, and 6, these are domain or number of domains. If you have 2, you really have only one choice. There is no lone pair, so that would be linear. If you have 3 domains, then you can have a 0 lone pair or 1 lone pair. Depending on these two numbers, we could have a triangle, planar, or a bent structure. Let's go to 4. So 4 is basically a tetrahedron. Now again, look at the lone pair. If you have 0, 1, and 2, so that means tetrahedron, trigonal, pyramidal, and bent, depending on 0, 1, and 2. Now if you have 5, that's trigonal bipyramidal. Again, we go from 0, 1, 2, and 3. Remember, 0, 1, 2, and 3. For each of those lone pair, we could have a trigonal, bipyramidal, seesaw, T-shape, and linear. Now, if you have octahedral, which is 6, we could only have 0, 1, and a 2. So that first one is 0 is octahedral, square pyramidal, and a square planar. So let's bring up the shapes. Maybe we can look at some of the shapes. Linear, so we have linear like CO2. We have trigonal like BF3. Bent like tin chloride. Tetrahedron, carbon usually is tetrahedron, methane. Then we have ammonia. So ammonia has a pair, one pair here, 3. So that would be trigonal pyramidal. And then the water basically would be a bent. So now back to original question that we had. So we have 1, 2, 3, 4, 5. So this would be a trigonal bipyramidal. Thank you.